All right, so our next lesson was solving multi-step inequalities. Inequalities use a different sign than the equal sign. You have greater than, less than, greater than or equal to, and less than or equal to. And the steps here, they're going to be the same as we solved equations. There's a few minor differences here. So the first step here is to distribute if needed. So if you see parentheses and you can't simplify inside of the parentheses, you need to look for the number directly in front of the parentheses or that negative / minus sign directly in front of the parentheses. That means you need to distribute, and you distribute that number outside of the parentheses, or you distribute that negative sign, which means to take the opposite, and you multiply it to the terms inside of the parentheses. After you distribute, step 2, you're going to combine like terms on each side of the inequality. That also works for equations as well. You want to do the left side of the inequality first, and then do the right side. So combining like terms, if you have more than one variable term on the left, you can combine them. If you have more than one number term on the left, you can combine them. So you're adding them or subtracting them just as they are. Then you'd repeat on the right side. There are times where there may not be any like terms to combine, and that's okay. But you need to check. Number 3, if there are variables on both sides of the inequality, and this goes for the equation too, move the smallest variable through addition or subtraction. Now this is specific to inequalities, but it can also work in the equations as well. Move the smallest variable through addition or subtraction. The reason they have that there is to keep the variable term positive. To keep the variable term positive. Number 4, solve the remaining 2-step inequality. So once we simplify it, once we move that variable term to one side or the other of the equation, then we have 2 steps left. We usually add or subtract the number away from the variable, and then we usually divide by the number in front of the variable. Okay, now here's where it gets more specific for inequalities. If you multiply or divide both sides of the inequality by a negative number, you must flip the inequality sign. The reason we do that is if you multiply or divide by a negative number, you're changing directions. So if you're changing directions and you're changing it and making it the opposite of that number, then you have to flip the inequality sign too, because it changes directions as well. And then we're going to graph and write the solution set. Directions. Solve each inequality and then graph and write their solution sets. So these are the same equations that we were solving previously. The only difference is that we have this inequality sign. I'm still going to solve it the same way. I see I have parentheses, cannot do anything inside, so I look on that number. On the outside, I have a -2. That means I need to distribute -2 to everybody inside the parentheses by multiplication. I have -2x minus 6 plus 4x is less than 2. Now I need to do step 2, combine like terms. I have a -2x and a positive 4x. They combine and equal 2x. So now I have 2x minus 6 is less than 2. Now I have the remaining 2-step inequality. I have my variable that I need to isolate. That means that -6 has to move by inverse operations. I'm going to add 6 to both sides. That zeroes out, and 2x is less than 8. Divide both sides by 2 to further isolate the variable. That equals a 1. So now I have x is less than 4. Now I have my solution and I need to graph it. I usually pick 3 points on the number line, my solution is going to go in the middle. And then I go 1 up to 5 and 1 down to 3, so I know which direction my inequality is going. Okay, I also have less than. So whenever I have less than or greater than sign, that does not include 4. 4 is not a part of the solution. It goes up to 4. I could have 3.9999999. That's a solution. But if I get to 4, it's not. So I need a way to represent that. And anytime I have less than or greater than, we use an open circle. Okay, so that indicates it goes up to that point, but doesn't include it. So I'm going to have a circle over 4. Then I need to represent x is less than 4. So I need to determine, is 5 a solution or is 3 a solution? If it's less than 4, 3 is less than 4. So that means that the left side of 4 are the solutions. And I draw an arrow to indicate that all those numbers from 4, 3, 2, 1, 0, all the way down, those are solutions. It goes up to 4 because it's open, and then it includes all the numbers from 4 down. We also represent it with an inequality notation. So we start with a bracket, then we name our variable, then we have a vertical line. And that vertical line is read such that, it actually has a meaning, such that, then I write our solution, x is less than 4. We have our solution, and then we end our bracket. This is called inequality notation. This is how we represent the answer, and we read it as the set of x's such that x is less than 4, and then we end the set. So the set of numbers for x such that x is less than 4, and then we end the bracket. Number 2. I have a parenthesis. It has x plus 1, which cannot be simplified, but it has a negative sign out in front. That means I need to distribute that negative sign, and I can look at it as taking the opposite of x and the opposite of 1, or I can write in a 1 and multiply by negative 1. I get negative x minus 1. My 5 is a separate term. It just comes down. And I have less than or equal to 6. Combine like terms. I have a 5 and a negative 1. That gives me 4 minus x less than or equal to 6. Isolate my variable. I'm going to subtract 4 from both sides. That zeroes out, and I get negative x is less than or equal to 2. But then I have a negative x. And again, because I have that negative, I could write that 1 in there. So if x is being multiplied by negative 1, I would need to divide by negative 1, and I should have flashers going off because that's a negative. Once I multiply or divide by a negative, I have to flip the inequality symbol. So I like to circle it and do a little flip sign. So now my x is greater than or equal to negative 2. Okay, well this time I have a greater than or equal to or less than or equal to sign, and that does include negative 2 as an answer. So I'm going to have a solid dot. I'm going to fill that one in, and that's going to make it so that I know 2 is a solution. Okay, 2 is a solution. So or negative 2 is a solution. So again, I like my 3 points. My negative 2 goes in the middle, and going up would be -1. Going down would be -3. So I know which direction my number line is going. We have -2. It is greater than or equal to, so I'm going to fill it in. And then it's greater than -2. So out of the two numbers I've chosen, greater than is to the right. -1 is greater than -2, so I know my solutions are going to the right. My solution set. Bracket, variable, my vertical line, my solution set, x is greater than or equal to -2, and then my bracket. So the set of numbers for x such that x is greater than -2. End the bracket. Okay, let me get to the next page. I'm gonna pause it. Now the next two problems we did in class, I actually had the students walk me through. I didn't speak. They told me what to do. So we'll do 3 and 4, and then the students did 5 through 9 on their own with their table partners. I have parentheses. Can't simplify inside, so that 4 on the outside gets distributed by multiplication. I get 12 minus 4x. Bring down the rest of my terms. So I have an 8 plus 12 minus 4x plus x is greater than -13. Combine like terms. 8 and 12 is 20. -4 positive x is -3x is greater than -13. Subtract 20 from both sides to isolate the variable. That zeroes out. I get -3x is greater than -33. Divide by -3. And my flashers need to be going on because I am dividing by a negative number. That means I need to flip the sign. So that goes to 1. X is now less than 11. Graphing my solution. I have 11. 12 would be 1 up. 10 would be 1 down. It's less than. It's open. It's less than, meaning I need to go to my left. My solution set, bracket, x, such that x is less than 11, end bracket. Okay, number 4, parentheses. 5/2 is going to have to be distributed. I get 8 is less than. Now my 2 here, coefficient, divides out with my 2 denominator, and that leaves me with 5x. 5/2 times 4. My 4 coefficient constant divides out with my 2, leaving me a 2, and 5 times 2 is 10. Then I have a -3x. Combine like terms. Combine my x's. I get 8 is less than or equal to 2x plus 10. Subtract the 10 from both sides. -2 is less than or equal to 2x. Divide by 2. That goes to 1. My x is greater than or equal to -1. Okay, so now I have my solution set of -1. That's going to go in the middle. My 1 up is 0. My 1 down is -2. I'm reading from the variable. You want to read from the variable. Okay, I do have greater than or equal to, so that is going to be filled. And greater than or equal to is to the right because I'm reading from the variable. My solution set is bracket x such that x is greater than or equal to -1. It does need to be written with x first. Okay, Now it's your turn.